A diamond's true age is difficult to process because it exists on a scale that doesn't align with our standard historical milestones. Most of us define ancient by the extinction of the dinosaurs, a point roughly 66 million years in the past. If we move back 200 million years, we reach the point where the Atlantic Ocean opened and the supercontinent Pangaea began to split apart. Shifting continents and mass extinctions represent the end of our historical maps, but in the life of a diamond, these are relatively modern occurrences. Our reliance on human-centric milestones makes it nearly impossible to visualize the true duration of geological time. The word old simply fails to capture the reality. The famous Cullinan diamond, the largest ever found, formed during an era that dwarfs these events. Long before it was split and set into the crown jewels, the carbon in this stone was already hundreds of millions of years old. The timeline continues even deeper, eventually arriving at a point before oxygen was present in our atmosphere. Diamonds are outliers that survive planetary transformations, remaining intact while the Earth's surface and atmosphere are completely rewritten. The famous Kimberley diamond formed during this early stage of Earth's history. Extracting stones from this depth required massive manual effort, pulling material from deep within the crust to reach these ancient layers. Determining the age of these stones presents a problem. Carbon dating is ineffective for anything older than about 50,000 years. Since the diamond itself is made of pure carbon, geologists have to find another way to calculate dates that reach into the billions. Solving the mystery requires looking past the carbon and finding a microscopic chemical sample trapped inside the stone during its formation. Tiny minerals are often caught inside the diamond lattice as it grows under intense pressure. Some of these trapped minerals contain radioactive elements. These elements act as a natural atomic clock, decaying into new elements at a predictable rate over billions of years. Scientists calculate age by measuring the ratio between the original element and the new element it decayed into. This radioactive ratio provides the mathematical evidence needed to verify exactly when the mineral was sealed. Diamonds serve as geological containers, shielding these chemical records from the destructive heat and pressure of the Earth's interior for billions of years. When scientists applied these atomic clocks to the oldest diamonds ever found, the results were staggering: 3.4 billion years old. To put that in context, these diamonds have existed for 3/4 of the Earth's entire history. They are some of the only surviving physical links to our planet's earliest development. While we now understand when these stones arrived, the mechanics of how they survived the early Earth's violent environment is still being uncovered. The forces required to forge carbon in the Earth's mantle are far more intense than most people realize. To see that process in action, subscribe.